Hi, my name is Vivien Chen, and today I'll be talking about the greenhouse climate. 175 million years ago, Pangaea began to break apart. As illustrated in the diagram, this was sometime between the Permian and Triassic periods. By 100 million years, the world looked very different, with its half-dozen smaller continents. During this time, sea levels were estimated to be at least 100 meters higher than today. The result was that it caused inland flooding, which led to further fragmentation of existing continents. This period was known as the Cretaceous, which is translated as abundance of chalk because of the marine limestone deposits around the world from high sea levels. Another difference was the lack of permanent ice anywhere on Earth, which is speculated to be indicative of a greenhouse climate. More evidence for a warmer climate comes from fossil evidence. In the northern hemisphere, fossils of warm-adapted vegetation, such as broadleaf evergreens, are found. Fossils of warm-adapted animals, such as dinosaurs, turtles, and crocodiles, were found north of the Arctic Circle. In the oceans, coral reefs indicated tropical ocean temperatures 10 degrees latitude further from the equator than today. Climate scientists modeled the Cretaceous greenhouse climate and produced a graph that looks like this. The x-axis represents the latitudes north and south, with the 0 degrees in the center, and the y-axis represents the temperature in degrees Celsius. As you can see, the Cretaceous climate was only a few degrees warmer at the equator compared to today. However, as we move towards the poles, you can see a greater discrepancy between the simulated mid-Cretaceous climate and today's. At the North Pole, temperatures were at least 20 degrees Celsius warmer than today. Likewise, in the South Pole, temperatures were at least 40 degrees Celsius warmer than today. This is primarily because of the absence of an Antarctic ice sheet in the Cretaceous simulation. In contrast, today the ice sheet reaches from 3 to 4 kilometers, and this makes the temperature significantly colder. Although life in the Cretaceous climate was very different, understanding the past climate will help us make future projections for the modern greenhouse climate.